Hello everyone, welcome back to the channel. I hope you are doing well, and in this lecture we are starting our second unit, that is AC circuit. In the previous lectures we have discussed the types of AC supply, okay, AC and DC, okay, but we prefer mostly AC due to its various advantages over DC, okay. We have discussed all this in the previous lectures. In this video we are going to discuss what is the cycle, frequency, time period of AC quantity given and how to find that, okay. What is meant by cycle, frequency, time period of AC quantity and how to calculate that, okay. So let's get started. First we will discuss some basic terms related to AC quantity, okay. First one is waveform. The waveform is the graph of magnitude of an AC quantity against time. It is a graph of magnitude of AC quantity against time. We know that AC quantity is the one which changes its direction as well as magnitude with respect to time. Which changes its direction as well as magnitude as well as direction with respect to what? Time. With respect to time. And this is known as AC quantity. And the waveform is the graph of magnitude of AC quantity against time. Okay. Okay. It may be, this is the sinusoidal wave. This may be like this. This is also changing its magnitude and direction with respect to time. This is also a waveform. This can be a waveform, okay. It is simply a graph of magnitude of AC quantity against time, is known as waveform, okay. Then instantaneous value. The instantaneous value of AC quantity is the value of AC quantity at a particular instant of time, okay. Suppose we have this AC waveform, sinusoidal waveform, as it represents a sine quantity, so the waveform is known as sinusoidal waveform. Sinusoidal waveform. Okay. In the upcoming slides, we will discuss the various types of waveform also. The instantaneous value is the value of AC quantity at a particular instant of time. Instantaneous name suggests that it is the value of AC quantity at a particular instant. Suppose this is the AC waveform, which is sinusoidal one, and this is the time axis, and this is the magnitude of this AC quantity with respect to time. Then at this instant, this will be the value, okay. This will be the value. At this particular instant, the value is 0. At this instant, it is negative maximum. At this instant, again 0. At this instant, some positive value is there, okay. There is some positive value. Suppose at this instant, some negative value is there, corresponding negative value is there. The values of a particular instant of time, the value at particular instant of time is known as instantaneous value, okay, instantaneous value, and it is represented by small letters. Suppose if it is a voltage, then small v, if it is a current, then small I, okay, at particular instant, okay. This is the waveform and instantaneous value. Next, see, there are various types of waveform according to the shape. This represents the sine wave, named as sinusoidal waveform. This represents these are the square, so it will be square waveform. This represents triangle, so it will be triangular waveform, and this represents sawtooth, okay, sawtooth, so it will be known as sawtooth waveform, okay. According to shape, there are various types of waveforms we have. Now see these diagrams. These are also waveforms. These are the sound waves, okay. The volume with respect to time is recording. When we are recording the voice, we will get these types of shape, okay. and these are the sound waveforms. Also, these types of wave are known as complex waveform, which is the combination of different AC quantities. Here we are 4 circles are there, and these 4 circles representing 4 different AC quantities having different magnitude, and the combination of these 4 will be this type of waveform. Okay. Now let's see what is mean by cycle. In an AC waveform, a particular portion consisting of one positive and negative part which are identical to each other repeats many times. That a portion is called as one cycle. Suppose we have this AC waveform here, and which is continuously, okay, which is continuously, but here we can observe that from here to this point, this part is repeated many times. This part is repeated many times, and the repeated part is known as cycle. Okay, this repeated part is known as cycle. But there is one condition, that this positive, suppose this is the reference axis, then this is positive part and this is negative part. Below the reference, this is negative part. It must be the area representing positive part must be equal to area representing negative part. That means this area must be same. Okay. In that case, when a particular portion of waveform is repeating itself, then it is known as cycle. And in case of AC waveform, this is the sinusoidal wave. This one positive and one negative part is repeating itself. This positive negative, again positive negative, here again positive negative. That means this part from here to here at this point this is the portion which is repeating itself, and this is known as one cycle. In terms of radian, this is 2 pi equivalent to 2 pi radians, and in terms of degree, it is equivalent to 360 degrees. Suppose this is the 0 point, then this will be the 2 pi radians or 360 degree, and this will be the half. So it will be 180 degree or pi radians, and this is the 0 degrees or 0 radians. Okay. This is the cycle of AC quantity. The part which is repeated is known as cycle. The part which is repeated, or the portion which is repeated itself many times is known as cycle of an AC quantity. Okay. Now, let's see here amplitude. The maximum or peak value of an AC quantity is called as amplitude. We know that the AC quantity or alternating quantity changes its magnitude as well as direction. The magnitude as well as direction with respect to what? Time. It changes its magnitude as well as direction with respect to time. And when it is changing its magnitude, at one point it will be maximum, at one point it will be minimum, and the point here represent the maximum value. Maximum value or peak value is nothing but amplitude. The maximum or peak value of AC quantity is called as amplitude of AC quantity, and it is represented by, if it is a voltage, then capital Vm. If it is a current, then capital I suffix M. Okay. In this way, amplitude is represented, and its unit is volt, because it is representing maximum peak value of AC quantity. Volt. For voltage it is volt, for current it is ampere. For Vm it is volt, for Im it is ampere. Then see angular velocity, which is denoted by omega. This is small w is known as omega, and it is the rate of change of angle with respect to time. It is the rate of change of angle with respect to time. We know that when there is a one revolution, one cycle is completed. One revolution of phasor represents one cycle, and one revolution is nothing but 360 degree, and one cycle time is nothing but t. And 360 degree also represented in radian as 2 pi and completed in t seconds, because t is the time which is required to complete one cycle, t. Okay. So It is the rate of change of angle with respect to time. So it will be omega will be d theta upon dt, and d theta is what? 2 pi or 360 degree, and dt is what? In t seconds. Okay, so omega will be 2 pi upon t. Then what will be this t? T is the time period here, time period of AC wave, which is measured in second, And what is the unit of omega? Omega is measured in radian per second. Angular velocity is measured in radian per second. So let's see time period. What is meant by time period? The time period of AC quantity is the time taken in seconds by the waveform and AC quantity to complete one cycle. This is important. The time taken in seconds by the waveform to complete one cycle. This is the one cycle of waveform, where it is the positive half or positive part, this is the negative part, and area under this positive and negative are same. So this will be the one cycle. And to complete this one cycle from this point to this point is known as time period. The time required to complete one cycle of AC quantity is known as time period, which is denoted by capital T and measured in terms of seconds. Okay, this is time period. Now let's see what is meant by frequency. The frequency, which is denoted by capital F, is the number of cycles completed by an alternating quantity in 1 second. Frequency is nothing but number of cycles completed in 1 second. Number of cycles of an AC quantity completed in 1 second. This is the number of cycles of an alternating quantity completed in 1 second. It is denoted by capital F and measured in cycle per second or hertz. Cycle per second. Number of cycles completed in 1 second is known as frequency, and it is 1 upon time period. Time period we have already discussed. Time period is the time required to complete one cycle, and frequency is 1 upon time period, and the number of cycles completed in 1 second. See here, this is the sine wave which is continuous. Okay, this is continuous. Suppose we are observing here at this point. We are standing here and observing this waveform, and we want the frequency. We want to calculate the frequency of this AC waveform. Okay, this sinusoidal AC waveform. Then we have to count the number of cycles which are completing in 1 second. So we are starting here at 0 seconds, and at this point, suppose at this point 1 second is completed. From this to this, 1 second is completed. Here at this point 1 second is completed, and we are started here, and we are observing at this point. So how many number of cycles completed in this 1 second is known as frequency. So calculate. This is the reference axis. Okay, here positive part, negative part, here also positive, negative, here also positive and negative. So positive and negative combination, one set of positive and negative is known as one cycle. So from here to here, one cycle completed. From here to up to this point, 2 cycles completed. Up to this point, 3 cycles are completed, and up to this point, 4 cycles are completed. That means 4 cycles completed in what? 1 second. So what will be the frequency? Frequency of this wave will be 4 Hertz or 4 cycles per second. In this way, we can calculate by observing this AC waveform, we can calculate the frequency. Okay. We can calculate this frequency. Now, let's do one task here. Here, we have given this small v equals to 25 sine of 314t volts. Okay, v equals to 25 sine of 314 volts, and we have to calculate here amplitude of this AC quantity, angular velocity and frequency. Here, How we will identify this? As here sine term is there, that means it is a sinusoidal wave. Sinusoidal wave. Okay, and every sinusoidal wave is represented by the standard equation. If it is a voltage, then Vm sine of omega t. Okay, if it is a current, then small I equals to Im sine of omega t. These are the standard equations of voltage and current. AC voltage and AC current. Here compare this equation with this equation. Comparing, we can find that this is the sign, is there. It's 25, this is Vm, that means Vm is equal to 25. Okay. And this omega, this sign in bracket omega t, here sign in bracket omega t. So omega will be what? Omega will be 314. Okay. And this Vm is the maximum value or peak value of voltage. Vm is the maximum value or peak value of voltage, which is also known as amplitude. Okay. So Vm will be, this will be in terms of volt, and this is radian per second. By comparing, we can write this. Okay. Here we want to calculate this amplitude. Amplitude is nothing but same Vm is 25 volt. So amplitude will be 25 volt. Then angular velocity is represented by omega, and omega directly we have this 314 radian per second. So omega will be 314 radian per second. Now calculating this frequency. Here frequency is given or not? Not given. Directly not given, but from this omega we can calculate. We have discussed that omega is equal to 2 pi into f, radian per second. Radian per second. So this will be the omega. We have this 314, we have this 2 pi, we want this frequency. So frequency will be 314 divided by 2 pi. Okay, this 2 pi. So it will be 50 Hertz. What will the answer? 50 Hertz. This will be the required frequency. In this way, with only one equation, we can find the amplitude, angular velocity, and frequency of the sine wave represented by this equation. Okay, let's do another task. Here we have given one waveform. This is the sine waveform where this point is marked as 100 volt. This is the pi point. This is the 2 pi point. Okay. And from this to this, from 0 to 2 pi, t is mentioned as 20 milliseconds. T is mentioned as 20 milliseconds. And from this waveform, from observing this waveform, we have to calculate this Vm, frequency, and angular velocity, omega. Okay, so let's calculate. We know Vm is what? Vm is amplitude or maximum value of AC quantity, So Vm will be, this is the maximum value and this is 100 volt. So Vm will be 100 volt. This is the first answer. Then what is frequency? Frequency, we know that frequency is 1 upon t, and 1 upon t is given as 20 milliseconds. So 20 into for milli 10 power minus 3, we will get this value as 50 Hertz. This will be our second answer. Then third will be omega. Omega, we have this 2 pi into f. So 2 pi into this 50, we will get this 314 radian per second. In this way, we can also find from with the help of this waveform, we can find this all the parameters. Okay. In this way, we can calculate the required values of amplitude, frequency, and angular velocity from the given data. Okay, in terms of equation or any waveform. Let's take another task. Here, one waveform is shown which is sinusoidal one, and one time is shown that is 8 seconds. Okay, and from this given data we have to calculate the frequency. This is the task for you, and solve this question and let me know the answer in the comment section below. We will appreciate and highlight the replies from you, okay, in the next video. Till then, stay tuned and keep learning. Thank you.